Happy day, students. So let's see today the mirror concept. Okay, it's basically the concept that we have studied with the basics of waves. Okay, now there can be certain questions which can be asked on the mirror as such, which is related to the basics. Okay, the first question that I am asking you is, if we assume that there is a source here and here is the mirror and here is the screen. First question is, are we going to observe an interference pattern on the screen or not? Answer is yes, we will observe. How? One, the wave will go directly, and other one will come to this and get reflected and go and interfere with this one. So there are two sources. One is formed by the reflection and other one is the direct. You can again say that if suppose this is source S, then its image will be somewhere here. And that way also we can understand it. This is S and this is S1. So now these are the two sources. Okay. So interference pattern we are going to observe on the screen. Now the second question is, what type of interference pattern it's going to be? We say that the options for that one is a straight line. Second is hyperbolic. Third is parabolic. And final one, circular. What will be the shape of the interference pattern? The answer is circular. Why? Because we already have studied that. If you remember the previous classes in which I told you that if the two sources are there in the same line, which is joining the sources with the screen, then we are going to get the circular fringes over here. How? Because we can say that here they are reaching in same phase. In a circle, at all the points, there will be equidistance from this point. Whether you are talking about this point, you are talking about this point, you are talking about this point, or you are talking about this point. Same for this one. So because of that means that on this circle, everywhere, the path difference will be same. So because of that, intensity also will be same on the circular path. Next to that, there will be a dark zone, then again there will be a brighter zone. So interference will be circular. Okay. Let us see another question based on this reflection. Suppose that source is here and this is the mirror and here is the source. Okay. Now, if suppose I say you that this is d by 2 and I ask you whether there will be an interference at this point, answer will be yes, obviously. There will be interference at all this point on the screen. If this is a screen, there will be interference. How? One by the direct wave and other one is the reflected wave. So the second question comes out, what is going to form here? Whether it's the maxima or minimum. At this point, suppose I say point P, whether it's maxima or minimum. The answer is minimum. Why? If I say that at this point, this is the source S and its reflection over here. This is S1. Okay. So one is a direct wave, another one is a reflected wave. Now you must know that whenever there is a reflection from the tensor boundary, it's a wave basics. If there is a reflection from the tensor boundary, then phase of the wave changes by pi radian or 180 degrees. If this is reaching direct, that's fine. But the wave which is reaching from here, one is like this and other one is like this. Okay? Between these two waves, there is 180 degree phase difference. How it came? It's the property of the wave. Okay? If the wave is reflected by a tensor boundary, then its phase changes by pi radian. Okay? So now, geometrically, both are traveling same distance. No doubt about that. Path difference is 0. But because this is reflected wave, 180 degree phase difference is associated with it. So because of this, at this point, how much will be the phase difference? Pi radian. and pi radian phase difference corresponds to minima. Okay, pi radian phase difference corresponds to a minima. So instead of maxima, what we are getting here? A minimum. Now, what can be the second case? Can we ask you that what is the distance between this minima and the first maxima that we are going to get over here? Now we know that between a minima and maxima, it's half of the fringe width. What it is? It's half of the fringe width. What is fringe width? Distance between two successive maximas. Okay? So here, this is minima and this is maxima. So this will be half of the fringe width. And what is fringe width here? Lambda d by d. Can we say the same thing over here? Yes, because we are considering this to be capital D and this to be small d. So lambda d by d. So by 2. So distance between this minima and the first of maxima that we are going to get is lambda d by 2. Okay, so what concepts we learned with the mirror? That whenever there is a reflection from the mirror, the phase of the wave changes by pi radian. Okay, fine then. Let us go back to IDSC, some of the questions we will solve. So, suppose that the question is like this. Here is source S. Okay, and here is a screen in which a hole is done over here and a hole is done. Okay, and this is the final screen over here. From here the light is going. In this X is another source, let's say S3, and this is another S4. So S3 and S4 are basically the sources, and here is the interference going to happen. Okay, so let's say here, and this point you can say is O. This is given D to you, this is also capital D, this is small d. Okay, wavelength is lambda. And as usual, D we can consider as very large as compared to small d. So what we have to find? Okay, we have to find that what is the minimum value of D for which there is minima at O. There is minima at O. Alright, and this one lambda is very small, then D is not given to us. Only given information is D is very large as compared to small d. So what to do in this? Now see, for minima to be at O, and that too he is asking minimum value of D. For that we can consider that at O there is first minima, because for this first minima only the minimum path difference is required. Correct? So first of all let's find out what is the path difference. If this is D, this is D, and I can say this is root over D square plus D square. This is also the same. Okay, so what is the path difference? Delta X we can say SS3 plus S3O minus SS4 plus S4O. That's the path difference. Right? Then SS3, what is SS3? We can see here root over D square plus D square plus S3O also root over D square plus D square, so 2 minus SS4 which is D, S4O is also D, so minus 2, and this is all equal to what for first minima? Lambda by 2. Okay, take 2 common over here. Lambda by 2 is equal to 2 D square plus D square to the power 1 by 2 minus D. This 2 you can bring over here, that's lambda by 4 equal. Now, this here relation is given to us that D is very large as compared to small d. So what I am going to do is I am going to take this D common. Take this D common. So when you are taking this D common, it comes D square. D square when it comes out, power is 1 by 2. So D square to the power 1 by 2 comes out. That means what comes out? D. In the bracket what is there? 1 plus D square by D square. Are you able to understand? I took D square common from here. Okay, so d square when it comes out, it becomes 1 plus small d square by capital D. Then d square I took it out of this bracket. Its bracket power is half. So it came out as what? D. Here is d square minus d. Okay, now what you can do? We already given that this small d is very less as compared to this. So I will be using binomial expansion over here. So in binomial expansion, what we can do? We write 1 plus this half, we write like that. And remaining terms we ignore. Reason being, this is very small. So 1 plus 1 by 2 d square by d square, and here minus. Okay, so multiply d inside, d plus d by 2 d square by d square minus d. This and this gets cancelled. Okay, see further. So what we have, lambda by 4 equal to, here this d also we can cancel, so d square by 2d. Sorry, d square by 2d. This also gets cancelled. So what we are getting over here? D square equal to lambda d by 2. So d equal to square root of lambda d by 2.